Welcome dear student. Today we will do a second part of the lesson force and pressure. So first part we have did yesterday, that is force and pressure. In that we have done force. Okay. Now today we will do the further part of the lesson. Now let's begin the okay. Now the first part of this second part of this lesson is inertia. Now we will see what is the inertia. Now students, the tendency of an object to remain in its existing state is called its inertia. This is why an object in a stationary state remains in the same state and an object in motion remain in the state of motion in the absence of an external force. That means the object at rest will prefer staying at rest position. An object which is in motion will prefer staying in motion. Now see students, this is the inertia is also called as Newton's first law of motion. Now let's see what is the Newton's first law of motion. A stationary object on which no force is acting remains stationary. An object in motion continues to move with same speed and direction when no external force is acting on the object. Okay, an object in motion continues to move with the same speed and direction when no force is acting on the object, and a stationary object on which no force is acting remains stationary. So basically the inertia is also called as a Newton's first law of the motion. You can see in the picture also, inertia is the tendency of an object to stay at rest or preserve its state of motion. That means it will moving continuously in same direction and same speed. Okay, to understand the inertia, let's do one of the activity. Now students, here I have put one picture for you. You can see the two parts. One is the see, when the cardboard is pulled, the coin falls into the glass. This is because the inertia of the coin maintain its state at rest and it falls into the glass due to gravity. Now student, why does the coin falls into the glass? Because of the force of gravitation. Now we will see the types of inertia. Types of inertia. So students, basically there are three types of inertia. First is inertia of rest, second inertia of motion, third inertia of direction. Now let's understand these types. Now first we will see the inertia of the state of rest. So students, an object in the state of rest cannot change its state of rest due to its inherent property. This property is called the inertia of the rest. Now students, you see, tendency of a body to continue its state of rest unless an external force act on it. So this is what state of inertia of the rest or inertia of the state of rest. Now you can see in the picture, this is an example of inertia of the rest, in which see, you feel or move forward or backward when sudden brake is applied from rest of the motion. That means when you, while our feet go with the bus, the rest of the body remains where it is due to inertia of rest. That is, we fall backward again. Now another example I am giving you, that is, when we shake a branch of the leaves get detached and then again that branch comes back into its original position. That means it maintains its inner state of rest. Now let's see the next type of inertia, that is inertia of the motion. So students, the inherent property of an object due to which its state of motion cannot change is called its inertia of the motion. So what is it? The motion continues. That means motion of an object is continue till external force act on object to stop the motion. This is called as the inertia of the motion. For example, a revolving electric fan continues to revolve even after it is switched off, and passengers sitting in the running bus get a jerk in the forward direction if the bus is suddenly stopped. This example you can see in the picture also. Now next type, or the third type of inertia, is the inertia of direction. Now let's see. The inherent property of an object due to which the object cannot change the direction of its motion is called directional inertia or inertia of direction. So student, this is also called as a directional inertia. Now see, an object does not change its direction unless an external force applied to the object. Okay, so this is called as a directional inertia. Now for example, if a vehicle in motion along a straight line suddenly turns, the passengers sitting in it are thrown opposite to the direction of the turning. So these all are the three types of the inertia. Now we will moving towards the another half of the chapter, that is a pressure. Now let's see the pressure. Okay students, you must have observed that tires of two-wheelers and four-wheelers getting pressurized, the air filling machine has a pressure indicating dial or a digital meter showing the digital reading of pressure. The machine fills the pressure to a certain value. You are aware that a force has to be applied for filling air in the bicycle tire with the hand pump. By applying force, so air pressure is increased and then the air is pushed into the tire. So students, are force and pressure related? So yes, force and pressure are related to each other. This we can see later in this lecture only. Okay, now student, we will do another activity to understand the pressure. Take some sharp pointed nail. You can see in the picture on the right hand side. So take some sharp pointed nails and push them into a wooden plank by hammering on their heads. Now take a nail and hold it with its head on the plank and hammer it down from the pointed end. When pressing the drawing pins into a drawing board, they get into the board easily. By applying a force using the thumb, one can push the pins into the board. On the contrary, while pressing ordinary pins into the board, while pressing ordinary pins with the thumb may get hurt. So what does this simple experiment tell? Okay, what does this simple experiment tell us? The nail easily penetrates into wood from its pointed end. From this, you will notice that when a force is applied on the head of the nail, it is easy to hammer it into the plank. Okay, use your brain power. It is easy to cut vegetables, fruits with a sharp knife. A blunt knife does not work here. Why does this happen? So students, a sharp knife has a thinner edge, so the area under the sharp knife is less than area under the blunt knife. Why? Because blunt knife has more area than the sharp knife. Hence, pressure exerted by the sharp knife is more than pressure exerted by the blunt knife on vegetables. So, the sharp knife is more effective than blunt knife. That's why it is easy to cut vegetables, fruits with a sharp knife. Okay, now let's see the pressure. Now before seeing all this activity, we will move towards the pressure. So students, what is the pressure? The force exerted perpendicularly on a unit area is called pressure. Now you can see in the picture also, the force is exerted perpendicularly on a unit area is called a pressure. Now what is your unit area? The area on which the force is acting, that this area is considered. And pressure refers to a force exerted on a surface area. Now students, force is the effect caused by the interaction of two objects which tries to change the state of the object, push or pull. This is a force. Now what is a pressure? Pressure is a force acting on a object. Now let's see the formula for pressure. So pressure is equal to force upon area on which the force is applied. Now we have the formula for force also, that is force is equal to mass into acceleration. Acceleration is speed or velocity. Now let's see the unit of pressure. The SI unit of force is Newton and it is denoted by capital N, and area is measured in m square. Therefore, the SI unit of pressure, what it will be? It is Newton per meter square, and it is also known as Pascal. In atmospheric science, the unit of pressure is bar, and 1 bar is equals to 10 raised to 5 Pascal. Now pressure is scalar quantity. Now student, in previous lecture I have told you force is a vector quantity. Why? Because it is direction as well as magnitude or mass. But pressure is a scalar quantity. That means the pressure only has a magnitude or some amount or mass. Now students, if area increases, pressure reduces for the same force, and if the area decreases, the pressure increases for the same force. And this is the answer of that are force and pressure related. So what is the relation between force and pressure? If area increases, pressure reduces for the same force, and if the area decreases, the pressure increases for the same force. Now let's take one of the example, that is due to natural adaptation, the bottom surfaces of camel's feet are broad. Hence, the camel's weight is exerted on a large area and the pressure on the sand is reduced. This is why camel's feet do not penetrate into the sand and it becomes easy to walk. See, larger area means the pressure is less. Let's move further. Now we will see the pressure on solid, liquid and gas. So first let's see the pressure on solid. Okay students, air pressure is exerted on all the objects kept in the air. When a weight is kept on solid, pressure is exerted on air. This pressure depends on the value of the weight and the contact area between the two. Now students, when we keep weight on a solid, the pressure is created on that, and pressure exerted on all the objects kept in air. Now let's answer some questions. So student, you must have seen a vegetable vendor carrying a basket on her head. She keeps a twisted piece of cloth on the head below the basket. How does it help? Why? So because by placing a piece of a cloth on the head of a vegetable vendor, see, it will increase the area. That means the piece of a cloth will increase the area on the head, area of contact of the basket to put the basket, since the load now fall on larger area, and the pressure is reduced and it is easy to carry the vegetable basket to the vendor. Now next question is, we cannot stand at one place for a long time. How then can we sleep on a place for 8 and odd hours? Now students, when we stand or when in standing position, the contact is there, weight falls on a small area while standing, okay, and providing a large pressure, small a while standing, small area and large pressure. When we sleep, weight falls on a larger area, producing small or less pressure. That's why we cannot stand at one place for a long time because of less pressure, because of more pressure, and we can sleep on a place for 8 and odd hours because of a small pressure. Now next is, for skiing on ice, why are long flat sky ski used? Now student, why this is so? Because long flat sky ski large produce large area and will produce, if it is producing a large area, then pressure will be small. Now let's see the pressure of. Now students, here we have to do one activity. We have to take a plastic bottle. Take a 10 centimeter long piece of a glass tube on which a rubber balloon can be fitted. This you can see in the picture. Warm up one end of the glass tube and gently push in the bottle at about 5 centimeter from the bottom, as seen in the picture. To avoid water leakage, apply molten wax on the side of the glass tube. Now fill water slowly in the bottle and see how the balloon inflates. What is observed by this activity? So, the pressure of water acts on the side of the bottle as well. Now students, we are moving toward the second activity. So, take a plastic bottle, pierce it with a thick needle at the points 1, 2, 3. Point 1, 2, 3 means from the downward. 1, 2, 3. As shown in the picture. Fill water in the bottle up to the full height. You have to fill the water completely up to the level, last level. As shown in the picture, water jets will be seen emerging and projecting out. As we will fill the water into the jet, what happened? The water jets will be seen emerging and projecting out. The water jet emerging from the hole at the top will fall closest to the bottle. The jet from the lowest hole falls farthest from the bottle. Also, jets coming out from the two or second hole at the same level fall at the same distance from the bottle. What is understood from this? What is understood from this activity? At any one level, the liquid pressure is the same, and also the pressure increases at the depth of the liquid. Now students, we will see the gas pressure. Now let's see the pressure of a. Now students, if a balloon is inflated by filling air by mouth, it inflates on all the sides. If a pinhole is created in the balloon, air leaks out and the balloon does not inflate fully. It is realized that like a liquid, gas also exert pressure on the wall of the container in which it is enclosed. All gases and liquids have a common name, fluid. Now what is fluid? See students, liquid and gases, only liquid and gases are called as a fluid. Why? Because they can be made to flow or move, because they are flowing or moving. The solid has definite proper shape and a size, but liquid have shape and not size. Okay, that's why all the liquids and gases are called as a fluids. So fluids in the container exert pressure from within on the walls and the bottom of the container. So a fluid enclosed in a container exerts its pressure equally in all direction at a point within the fluid. That means a container in which a liquid is filled, the liquid will exert its pressure in all the direction of it. So student, this is all about this lecture. Next part of the lesson we will continue in the next lecture. I hope you have understood this well. Thank you students.